Hello, hi. In this video, I'm going to discuss another important question of AS1. I start with the question 2. Parcel of mass of 15 kilogram drop from a delivery cart into the conveyor belt. Here we have a diagram that is a conveyor belt, okay? And the parcel has mass of 15 kilogram. This parcel has mass of 15 kilogram, and this is a conveyor belt, okay? Here the belt is moving at the steady speed of 1.7. So steady means the constant speed of 1.7. The parcel lands on a moving belt with a negligible speed and initially start to slip. It takes 0.282 seconds for parcel to gain enough speed to stop the slipping and move at the same speed as the conveyor belt. Mean after some time, this load, this mass must be moving at the as the conveyor belt is moving. So both are moving at the same speed after some time. Okay, now we have to find the change in kinetic energy. So in order to find the change in kinetic energy, here first of all we'll discuss what is change in kinetic energy and how to find this change in kinetic energy. So this question can be solved by a simple principle, that is the work energy principle. Work energy principle. According to this principle, when you perform work on any object, work performed must be equal to must be equal to change in energy, change in kinetic energy. When you perform work on any object, it changes the kinetic energy. What work must be equal to change in kinetic energy? What does it mean? It means when we perform work on this parcel, when we perform work, but what do you mean by work mean when we apply force and the body covers some distance. So there is some force that is moving this parcel, and the distance is covered. So force into distance is the work done when you perform work. So the energy, this energy of this parcel changes from here to here. For example, how energy changes? Because as initially it is not moving, or its speed is less. When the you apply the force, it covers some distance, so its speed increases and its speed becomes 1.7 meter per second. Mean speed increase mean it has the kinetic energy, its kinetic energy changes due to the work done. So simple, change in kinetic energy is equal to work done. Simply we write that change in kinetic energy equal to work done. So first of all, here we have to find the change in kinetic, that is 1 over 2 m v square. So first of all, we find the change in kinetic energy. Half m is the mass, that is 15 kilogram, and speed v is the speed that is given 1.7 meter per second inverse square. So change in kinetic energy is equal to 22, or and we have in round of these to the two significant figures, that is 22 joule is the work done. Okay, now we move forward and we discuss other part, second part. The average horizontal force acting on the parcel during this is 0.82 second is 31 newton. So average force is 31 newton, and the time is 0.82 second. Calculate the horizontal distance. So we have to calculate the distance, horizontal distance, s between the parcel and end of the delivery cart, 0.82 second after the parcel land on the conveyor belt. Assume that the parcel does not reach the end of the conveyor belt. So simple, in order to find this, we use work energy principle as I mentioned above. Work energy principle, that work must be equal to change in energy, change in kinetic energy. So work is, we know that work is F into S, that is change in kinetic energy is, that is we have found in the above, that is 22 joule. So we have to find S is equal to 22 joule divided by that is the force F, and F is equal to, that is given in the question, that is 21 Newton. So we get distance covered, which is 0.709, and when we round up we get 0.71 in two significant figures. So this is the distance. Okay, okay, now we move forward and we discuss at the later stage the parcel being raised. So basically we have raised this level. Okay, so 18 degrees the angle of this inclination. So the speed is 1.7 meter per second, and we have to find the rate at which the work is being done. So in order to find the rate means the power. Okay, rate means something, work done per unit time. In order to find the rate of doing work, we use the equation that is equal to, that is power is equal to uh, rate of doing work equal to, as we know that when work is performed on this again, now its potential energy changes, the system potential energy changes, because you perform work from here and you go there, and when the parcel reaches at the highest point, so it means there is a change in its potential energy, gravitational potential energy, GPE. So it means the work performed must be convert its must be equal to gravitational potential energy. Okay. So we can write W as mgh, and del t is the time. So we can write W del t is equal to mg h over t. That is the height per unit time. Okay, mean the body covers the height. So in order to find the h over t, this is the distance covered, height covered by the parcel per unit time. So this is actually the speed v. So if we resolve this speed into two common, because there is angle, inclination angle is 18 degree. Okay, so if there is angle of 18 degree, so it means we have to resolve this speed into two components, that are horizontal component and the vertical component. So Vx is the horizontal and Vy is the vertical. So as we know that only the vertical component Vy contribution must be added. So we can write Vy only, because speed is defined as distance over time. So here distance is h over t. You can see that. So actually the only vertical component is utilizing, because the parcel is moving vertical. So its vertical component is effective component here. So we can write mg Vy, and so Vy is, we can write del w over del t equal to mg Vy is equal to V sine of 18 degree. So we can write mg is the mass, that is 15 kilogram. G is 9.81 or 9.8 meter per second square, and V speed is given, that is 1.7 meter per second, and sine of 18 degree. So rate of doing work we can find by this equation, that is 77.3 watt is the rate of. So actually here only vertical component is utilizing, because the parallel component of this, only vertical component must be contributed in order to find the total rate of doing work or total potential in. Okay, I hope so you this question is